I'm Oskars. I work for eazyBI for almost 2 years in support, and I'm going to tell you about a little bit introduction in what is MDX, what is multidimensional data cube, and what are the main concepts. But before going into theory, I took one object with me. So, you see, it's a book. It's paperback. It's, it has some characteristics like language, it has its genre, it's paperback or hardcover book, and it has some numbers associated like number of pages, and it is also associated with time. So it has some dates when it was written, when it was first published, when this was printed, also the date when I bought it, and date when I started reading, and eventually also the date when I will finish this book. And it has price. So those are like simple characteristics of a single object. Okay, we have one object. We have, let's say, 5 books. 10 books. We can have those characteristics written down, and when we need to see something, we can just look up on a list. But imagine if you have 1,000 books. You will need to start categorizing them to see. Or, for example, when I was moving to a new apartment, I was wondering how much does my children time books weight? Because I will need to carry them over. And when you have 5 to 10 books, you can just put them on scale. If you have 1,000 books, you need to calculate how many lorries will you need, or 10,000 like in library, or even more. So when you are going to report on a plenty of objects, you will need to categorize them. And that's the way of categorizing we are using as dimensions. So we are slicing our whole data set by dimensions. And, well, so one book and tens of thousands of books. Okay, then let's get back to theory. So, yeah. Okay. So I will cover a few topics, like first, what is and why we use MDX, what are the main MDX concepts, and I will slightly touch what is report context. So MDX is multidimensional expressions. It's a language for querying online analytical processing databases. It was created in early 90s by Panorama Software. It was later sold over to Microsoft, and in 1997 Microsoft proposed it to become a standard, and it was adopted as a standard for OLAP processing. There are still several versions, and there are slight differences, but the main concept is the same. So, multidimensional data cube, it's like, for example, issues. They have priority, they have project, they have time. And on a cross-section of those dimensions stand numeric values. Those are measures. Those dimensions, like priority or project, they have hierarchies and levels, which I will touch a bit later. So the point why we use MDX, you can see this sample chart. There, yeah. It could be made in just a few minutes or even less. It has some, you can just drag and drop priority on pages, status to columns, and assignees to rows. and choose just one measure, issue is due. It's like just drag and drop, maybe 20 clicks. So how it, that's what you see. On a background, eazyBI creates MDX query, which is a bit longer, but you can still read it and understand what is on your screen. But after eazyBI creates this MDX query, on a background, Mondrian engine creates SQL query, which is quite longer, and you would not like to write that by your hand. That's, we'll move further and add a standard calculation. It would be like additional 5 clicks on that report. And this calculation is, what was that? Average time in resolved for all statuses. So it was like up to 5 clicks on a report. It created MDX calculated member, which created the MDX query on the background, and SQL queries which don't fit on the page. We are using MDX and Mondrian engine to make it easier and simpler for you to create reports. You could, of course, write those SQL queries, but that would not be very efficient. So, yep. Okay, what are the advantages of MDX? eazyBI creates MDX expressions automatically. Users can expand existing MDX by creating their own calculated members. And Mondrian stores results in cache. Therefore, Mondrian runs SQL query to the database when there are no cached results. It means if you have the same report being executed during by 10 or 10,000 users, the first time Mondrian will have to request data from database. If nothing changes, then next executions will already launch from the cache, and they will be quite faster. So let's go through this, through a sample of what is like data cube or some dimension. And I borrowed this presentation from Diana, who created it about, I think, 5 years ago or so. And well, we have multidimensional data cube Simpsons, where we have a whole bunch of characters. They have their own characteristics. There are many families, many characters, and definitely many ways of analyzing them. And we will take one specific family, Simpsons themselves. And dimensions only get their meaning when they are used together with measures. So we have the family, and in the middle we have facts, like age of characters or number of characters, count. We have multiple dimensions which could describe those characters. But the default measure we are using is count. So, for example, dimension family has one hierarchy. It has like all families, specific family, and then family members as such. Any of those 10 displayed dimension members could be a current member depending on report context. So this is a default member, which is all characters or all members of the dimension. But some dimensions can have several hierarchies, depending how we group those members. For example, all occupations, they could be grouped by skill level or by position seniority. It's a junior position or a manager or a senior manager. But there could be like no specific categorization, and just all occupations and all occupations as such. And the main benefit from having hierarchies is that those at all levels results are pre-calculated and pre-aggregated. So you don't need to count all actual occupations. You could, if you need just skilled result for skilled occupations, you just look at the skill hierarchy. So on the second level, you just take the skilled professions. Okay, so now we have this set of family members. There are, like, on family hierarchy, we had 3 levels. Default level, default member, which is all members. Then we had the family level, where we have specific family. For example, this will be Simpsons. And this family Simpsons has, as a member, has its own properties. It has its name, Simpsons. It has its address. It has its first appearance. And we can get those properties by addressing family, Simpsons, and get property name. But that's family. And now we will go deeper to the lower level where we had family members. So all individual members like Marge or Homer. And they all they have their own properties like name, occupation, characteristics, and we can get their name as a string just for displaying by addressing member.name. So this will be a small recap of basic concepts within MDX, like dimensions. Dimensions is a way of categorizing your data. Dimensions use hierarchical structure to organize members, to organize those all categories in subcategories. Measures are the ones that glue dimensions together and provide you the actual result. And properties are attributes of members. When there is no member, there are no properties. Okay. So our set of family, and we'll check. So we have 7. So we are currently including both people and animals. And the measure is a treasure. And dimension itself is just a set. And now we will use family members, and we will choose only human. And that gives us measure count. When we're using those dimensions, we get context, and then we get result for measure. You see, cat and dog don't have measure because they are left out by the dimension human. So tuples is the next concept, and it's a way of addressing cross-join of dimensions. And tuple works within and can override existing report context. For example, we have this family, we have selected family, a specific family, we have selected gender, and we have selected humans. And that gives us 2. It's Homer and Bart. Then we can define a tuple and create a new calculated measure, children, which will include count, which will include human, and it will look for child. And when we use that measure, we see 1. Why? Because this measure is taking into account a report context. We still have this gender male selected. Therefore, we only get Bart, and we are leaving out Lisa and Maggie. There is also an option to override all context and leave out those selected dimensions by using default context. I will barely show it now, but Zane during the day will explain more on that. And in this case, we are taking measures, count, we are taking humans, and we are taking a specific family. But with default context, we are resetting gender. And then we are getting 5. So, like recap of mentioned concepts. Measure works in report context. When using a member, there's always a measure. If you don't have any measure specified, then default measure number of items will be used. And with tuple, you can override report context, but set as a such has no context. You need to use some measure to filter on the set. So what have we covered? What is MDX query and MDX calculated member? And we know that measures glue dimensions together, and current member represents a member in a report or set context. There is no such object as a current set because set lives by itself. Tuples take into account report context, and you could modify this. And set doesn't take into account context because set lives as itself. So generally that's it. Any questions?